Hello, welcome to Algebra 2 Common Core. Today we're going to talk about how to arithmetically combine functions. So in our first example, we're going to look at sums and differences of functions. We've defined two functions, f of m is equal to m squared plus 2m minus 8, and g of m is equal to 2m squared minus 3m plus 1. We want to find the sum of the two functions. So to find the sum of these two functions, it's just a matter of adding the two functions together. So if we've got m squared plus 2m minus 8, and we want to add on 2m squared minus 3m plus 1, we can line them up one right underneath the other so that we can add together like terms. The first sum is going to give us 3m squared. When I add together positive 2m and negative 3m, that's a negative m. Negative 8 plus 1 is giving me a negative 7. So the sum of the two functions, 3m squared minus m minus 7. The next example has us subtract the function g of m minus the function f of m. So when we do that, we are going to start with our first function, which is going to be the function g of m. So I'm going to take 2m squared minus 3m plus 1, and I'm going to subtract from it the second function, f of m, which is m squared plus 2m minus 8. The order in this subtraction is very important. Now, since we are subtracting, we could also go through and change all of the signs in the second polynomial to their opposites. So we could rewrite this as 2m squared minus 3m plus 1, and then change this to a minus m squared. I would also have a minus 2m. And because we're subtracting a negative 8, that would be plus the number 8. Now combining like terms, we're going to say that 2m squared minus m squared is giving us an m squared. Negative 3m minus 2m is a negative 5m. And the last pair of like terms, positive 1 plus 8 gives me positive 9. So my final solution would be m squared minus 5m plus 9. For the last example, we're still doing a subtraction, but this time we're going to put it in the order of f of m minus g of m. So the first function, m squared plus 2m minus 8, we'll subtract g of m, which would be 2m squared minus 3m plus 1. Now take a minute and go ahead and do that subtraction, pause the video, and come back and check your answer. I got as my answer negative m squared plus 5m minus 9. If you need to, go ahead and change the signs of the second polynomial and add together your like terms. For exercise number 2, we want to find the product of the two functions h of x and k of x. So we want to multiply together 3x plus 1 and x squared plus 4x minus 2. So you'll remember from last week, we set this up as a tabular problem. You could also do this as double distribution if you wanted to, but I'm going to write 3x plus 1 along the left side of my table, and I'm going to write x squared plus 4x minus 2 along the top. So doing the products, I'm going to multiply 3x times x squared and get 3x to the third. 3x times 4x gives me 12x squared. 3x times negative 2 is negative 6x. 1 times x squared is just x squared. 1 times 4x is of course 4x. 1 times negative 2 is negative 2. Remember to look along the diagonals for the like terms to combine them. So for our final answer, we are getting 3x to the third power plus 13x to the second power minus 2x minus 2. Now in exercise number 3, we're going to do the quotient of two functions. But notice that we are evaluating the functions first and then taking the quotient of the outputs. First of all, do me a favor and change our variables. I made a mistake when typing, so it should be q of x is equal to the square root of 6x plus 1, and r of x is equal to x squared minus 2. So in the numerator, we want to evaluate q of 4. So our input is 4. When we substitute 4 for x, we're going to say 6 times 4 plus 1, which gives us the square root of 25, which has an answer of 5. So the output for q of 4 is 5. When we do r of 2, use 2 for our input in the r function. So 2 squared minus 2 gives me an answer of 4 minus 2, which is 2. So when we substitute these into our quotient, q of 4 is equal to 5, and r of 2 is equal to 2. So the quotient of q of 4 and r of 2 is 5 over 2, 5 halves. We're going to skip exercise number 4 right now in your notes and proceed to the back of your note packet. Tomorrow in class, we'll take a look at exercise 4 together. The last operation that we're going to look at is called composition of functions. Composition of functions means that one evaluation of a function follows the next evaluation of a function. So we begin with our input value x. The input goes into the function f first of all, and then we take our output and we substitute the output into the function g to get our final output, which will be our final answer for the composition. Composition actually has two different notations that we can use. One notation for composition is the parentheses notation. So f parentheses g of x. We would say that as f of g of x. Now we can also write composition using what we call circle notation. So this is when we write f with a little circle, it almost looks like a degree symbol, g of x. For exercise 5, we will take a look at the composition of the functions f of x and g of x. F of x is defined as x squared minus 5, and g of x is defined as 2x plus 3. So in the first example, we want to take a look at the function value of g of 1. So we can say this as f of g of 1. When we are doing composition, as we are in this example, we always begin with the inside function. So we are going to start with the input 1. We are going to put the input 1 into the inside function, g. So when we substitute 1 into g, do the calculation with me. 2 times 1 plus 3 gives me an answer of 5. Now, this number 5 then becomes the input for our outside function, f. We take 5 and we put it into the f function where we see an x. So we're going to say 5 squared minus 5. 5 squared is 25. 25 minus 5 gives me 20. So our composition answer would be equal to 20. Notice that this involves doing 2 steps because we have 2 functions that we are composing. Now it's important that we recognize which function comes first. So in our next example, g of f of 2. We are again going to start with the number 2 as our input. But this time the function that we start with is f because that one's on the inside. If we can do this in our head, 2 squared minus 5 gives me a negative 1 for the output. That becomes our input when we then enter into the function g. So negative 1 gets substituted into the g function for x. So when we do this, 2 times negative 1 plus 3 gives me a final answer of positive 1. So g of f of 2 would be equal to 1. The next one's a little bit different because we're starting still with the number. The number on the inside is 0. You'll notice that we use the function g first, so we substitute 0 in for x in the g function. 2 times 0 plus 3 gives me an answer of 3. But then we recognize that the outside function is also g. So we reuse the very same function again, but this time we substitute 3 into the function g. 2 times 3 is 6. 6 plus 3 is 9. So our final answer for this composition is the number 9. Let's try one more, this time in circle notation. For circle notation, we do it exactly the same way. We're going to start with the input negative 2. But this time we go from right to left, and we say that g would be the function that we substitute into first of all. So when I substitute negative 2 in for g, 2 times negative 2 is negative 4. Negative 4 plus 3 is negative 1. Then we go to our next outside function here, which is going to be our function f. We use negative 1 as the input using the function f. This gives me negative 1 squared minus 5. Negative 1 squared is 1. 1 minus 5 gives me a final answer of negative 4. So this composition would have an answer of negative 4. Now there's nothing special about having 2 functions to do a composition. We could have 3 or 4 or 8 functions to do a composition with, each time entering the output of the previous function into the next function to get a new output. Now I'd like you to take a few minutes, pause the video, and solve for E and F. Welcome back. Check your 2 solutions for E and F and notice that both of them give us an answer of 11, but by different steps. Check your work and make sure that you've substituted the inputs into the correct functions and gotten the correct final output. If you have any questions, please come and see me in the morning. For our next examples, we are using composition of functions by using graphs to find the inputs and the outputs. So for the first one, we are going to start with the number 2. We are going to look to the function f. We find that on a graph, and we find that the answer at the number 2 is the answer 3. The output is 3 using function f. Now we substitute that as input into our g function. Going to the g graph, we look for the answer at 3, and we see that the function value there is also 3. So our final answer for the composition this time is 3. Now take a look at part B. We want to start with the input negative 1 and look to the g function to find the answer. So at negative 1, I see that my g function has a value of negative 5. Now we go to the f function, and at negative 5, I see that my answer is right about here, which means that I'm at -1/2 for my output. So the final composition, -1/2. Let's try one more of these using the graph. So we see that we are starting with 1. We are looking at the g function at 1. At 1, my answer for g is 3. But then we're reusing the g function with a new input of 3. We've done that one before. At 3, our answer again is 3. So my final answer for C for that composition is 3. For the last 3, please pause the video and you do the composition. Notice that these are in circle notation, but remember we always read from right to left. Come back and check your answer when you have completed it. Welcome back. Check your solutions and your work with what I've shown on examples D, E, and F. If you have any questions about composition, please see me during activity period. You'll notice that we skipped exercise number 4. Exercise number 4 will complete together in class tomorrow. Thanks. Have a great night.